Hello and welcome to Applied Logistic Regression, a data-driven approach to classification. We are going to be together for the next little while, so let me give you an idea of what you've got in store here. First, a quick introduction. Now let's dig into the course. The focus of this course is on logistic regression, a statistical technique which we can use for solving some types of data science problems. Throughout this course, we are going to learn what logistic regression is, understand the math behind how it works, and create logistic regression models in both R and Python. There will be 6 key topics in this course. The first topic is the basics of logistic regression. Here, we will get an understanding of what terms like regression and classification are, as well as learn some of the key assumptions behind logistic regression. The second section focuses in on the mathematics behind logistic regression. We will talk a bit about statistics during this, though my assumption is you don't necessarily have a background in stats. For that reason, we'll keep the math to just what is necessary to understand the algorithm. From there, we will dive into our example, a simulated data set which represents a set of traffic moving across an aircraft's data bus. We will apply logistic regression to this information to help us predict whether a given set of traffic is malicious or not. In the fourth section, we'll dig into the question of what makes a model good. We will look at a variety of ways to gauge the quality of a model, including the perhaps appropriately named confusion matrix. After looking at what makes a model good, we'll relax one of the assumptions of logistic regression and introduce the idea of multi-class problems, focusing on 2 varieties, multinomial and ordinal. Once again, we will provide solutions in both R and Python. Once we've taken care of multi-class logistic regression, I'll provide you some tips and tricks to make your life easier. Finally, we will close out the training with a brief wrap-up. There aren't too many requirements for this course. You'll need a fairly recent operating system and at least 5 gigs of storage for the Anaconda distribution of Python, as well as the R programming language. If you have Docker installed and configured, you can just grab an image I've created and spin up your own container to follow along. Otherwise, the accompanying Git repo will have details on what you need to set everything up. As far as knowledge goes, I don't assume any knowledge of R or Python, though having that would be helpful. Similarly, some statistical background would help as I talk about concepts like distributions and density functions. I'll keep it as simple and straightforward as possible, though you may need to do a bit of independent research alongside this if your stats knowledge is rusty. And with that, I hope you're as excited to go through this course as I am in delivering it. Let's go!